Hello, this is Jose Luis here at Parametric Camp, and welcome to another hands-on exercise on this series Advanced Development in Grasshopper. In this video, what we're going to do is we're going to prototype a bunch of components for this plugin that we're designing, the Parametric Camp plugin or whatever that is. And specifically, the components that we're going to be working on right now are documents that are going to be a little more meta, if you will, because the operations that they will do will be operations on the Rhino document, the Grasshopper document, and will be operations with the components that are living in the same definition as these components. The idea is that with this exercise, I would like to teach you a little bit more of the nitty-gritties and the deeper ends of what can we do with code inside of Grasshopper by using specific interfaces and specific classes that we have available in scripting that give us access to properties and to methods that are particular to the Rhino document, the Grasshopper definition, or other components that live in the same definition. So for example, what I would like to do is we're going to write a component that is going to take a look at the document, the Rhino document that we have open right now. And as you can see, I still have that head that I used in the previous video, right? That one mesh. And what we can see is that this Rhino document is going to have this name, it has this path on the file system, and it lives in this folder. And right now, the document contains one object. Similarly, because we are building up on that larger prototype file for this plugin that we're building up, I will create another component that will be taking a look specifically at the Grasshopper document that is owning this component, and it will give me its name, it will give me where it lives on the system, it will give me how many objects this component has, and even a pre-visualization of the thumbnail, which I will be rendering here in Grasshopper using Firefly, the plugin. Similarly, you know how I'm going to turn on this dummy box here, some dummy geometry. Similarly, I would like to teach you how to change things about how the document, the Grasshopper document, behaves, for example. And you know that we have the settings for document preview colors. So the fact that these objects, Grasshopper objects, look with a particular color on the screen, and by default this is red. But you can see that with this component, I can change the preview color and the transparency of the objects that are previewed from Grasshopper here inside of Grasshopper. And the same for the ones that are selected. So if I select this is the color for selected geometry. So I'm going to make this very dark blue. And for non-selected geometry, it's going to be this purple. All right. So you can see that from Grasshopper and within Grasshopper with code, I will be able to modify some of the properties of the Grasshopper definition itself and the way it works. And last, similarly, I would like to write some code and teach you how we can write components that look at other components, see their properties, and perhaps actually change those properties. So for example, this component, what we're going to do is we're going to take a look at all the other components that live in this Grasshopper definition. We're going to see the ones that are heavier computationally, the ones that are more expensive, that take longer to execute. Like for example, this dummy component here that has a for loop that runs 100 million times, right? We're going to read them and we're going to get properties from them, their names, how many milliseconds they took to execute, and the ID. And once we have their IDs, we will be able to manipulate them with other components, such as, for example, adding to those components a message that says, hey, this is a heavy duty component. Or for example, I think I have another one here, the remeshed. That one is also flagged as heavy duty because it's over 100 milliseconds in computation. But again, this for me is a way to explore and to teach you how to use Rhino Common, and especially how to use the Grasshopper SDK and the access that we get to the Rhino document and to the Grasshopper document by using these properties, the component, the Grasshopper document and the Rhino document, of the C# script components that we write our code in. So if you want to learn more about like how all these things are intertwined and how we can make these hacky meta manipulations of Grasshopper definitions using code, then perhaps this is going to be a fun exercise for you. Otherwise, if you're not interested in this, you're more than welcome to continue to the next video on this series. If you want to learn more about the Grasshopper SDK and where it is and how to read it, I suggest that you check my previous video on this series where I explain a little bit of that. All right, let's get hands-on and let's get started. Let's get started. So the first component we're going to write is a simple component that takes a look at the RhinoDoc document that this Grasshopper file is currently attached to. And then it takes a look at properties of that Rhino document. So for example, interesting things could be the file name and the path, for example. How can I access those? How can I access from the Grasshopper component? How can I access the document or an object that represents that document? Well, if you remember, if we expand this area here called members, we can see that the Grasshopper script component has a member that is called the Rhino document and is of the type RhinoDoc. Turns out that this is going to be an exception to the Grasshopper SDK because the RhinoDoc is not managed by the Grasshopper SDK, it's managed by Rhino Common. So if we go to the Rhino Common documentation and I type here, what about RhinoDoc? Do you have something for me? You can see that there is a RhinoDoc class. So I can click here and I can just go back to the main class and learn that there is this thing called the RhinoDoc class that represents an active model. And we can see a lot of things. We have a lot of properties. So we have the bitmaps for the textures, we have fonts, we have whether it's available or not, it's read-only, we can access the lights, the materials in the documents. We can actually get a lot of stuff from the document into our component. So we can also access the path. This will be super interesting for us, the runtime data and or the views. And then we can also change things. We can create a new RhinoDoc, we can dispose it, we can load from a file, we can get hash code, open documents, save documents. There's a lot of things that we can do, which is kind of interesting. Okay, so if we were to look closely to the documentation, we would get to know that, for example, for the output file name, if we access the Rhino document object that we have available for us here, dot, we can access all of that, all of those properties. So I'm going to go to, I forget, I'm going to use name. And I believe name is the name of the currently Rhino document that is loaded, the 3D file. So if I do that and I execute, you can see that I get the name of the file. So that's one thing. And I may also want to get which is the path of that file. So for path, I'm going to do Rhino document dot file or path. I may want to do. Okay, so path. All right, cool. However, something that I don't like is that if I'm saying path, I may just want just the root folders, the folders that take to this file, but not the actual file itself. So that can do two things. One thing would be perhaps it would be much more correct to call this the file path. So if I do that, then file path should be this whole thing. That's one thing. But if I also wanted to just have the path to the folder, which is something that we've seen in the past that is quite useful. So something that I could do is I could add here a new calculation that is, I'm going to use the system.io namespace, which is the namespace in C# that takes care of, that gives us functionality for accessing the file system. And then what I'm going to do here is that the path, I'm going to calculate it by using the path object that lives in system.io. And then from a full file path, I'm going to use the get directory name function that, given a full file path, it just gives me the path part of that full-fledged file path. So basically just the folders without the name of the file. All right. So I can just use file path, pass it there. And then for that is like, oh yeah, because this is an object. So yes, so because this is an object, that I'm saving the path to, I cannot use this as an input for this file, this method, which expects a string. So easy peasy. So I'm going to basically just create a variable that I'm going to call p, and that's going to be the path. I'm going to spit out that variable right away, and then I'm going to use that variable for the path, okay? And then if I plug this in here, you can see that now I have the file name, the full file path, and just the path, all right? Which is kind of interesting, all right? I could also create other things, such as, for example, how many elements are right now active in the document. Is that something that we can compute? Let me see. So if I look at objects, I can probably say I have no idea. For example, objects. So let me see if that works. I've never done this before. So object is going to be equal to, for example, Rhino document dot objects, and that gives me a table. And maybe there's something like count or something like that. And if I do that, this is going to give me the value of 1 because I actually have a file that contains this mesh. So if I were to delete the mesh and recompute this, I still get one object. Okay, I don't know. So what about if I copy this, etc.? Do I recompute? And I have 5 objects now. Yep. So maybe I didn't recompute correctly, or maybe it just keeps an instance of the object just hidden in memory or something. I'm not sure about that. So I'm going to save this. I'm going to recompute here. And you can see how it's still doing 5. Interesting. I don't know why that's the case. So why do I still have 5? That's something to explore further, I think. But I wonder if I just close this and I open it again, I still have 5 elements. That is not no template. And I'm going to recompute, and you can see that there's no elements. And I'm going to load the previous file. I'm going to recompute, and I only have 1 element. So it looks like there's something about those elements remaining in memory or in the table that's kind of strange. Anyway, so that was properties for the Rhino document. What about properties for the Grasshopper document, the file that we're currently working with? So I have gone ahead and I have created this empty C# script component that doesn't take any input. It doesn't need it, but it's going to output something very similar. The file name, the path, how many objects are present in this document. And for this one, we're also going to retrieve the thumbnail. Take a look at how this works. So for example, if we expand the members, we can see that we had an instance, we had an object for the Rhino document, but we also have a reference to the Grasshopper document that owns the component that we're writing code in. So what that means is that we can get access to a lot of stuff from that component. So for example, for file name, I can say Grasshopper component, and whether if you do this or not is entirely up to you. It's not mandatory. But for example, here I can say, what is the file path? All right. And the file path is going to give us the full path of this object. So perhaps what I want to do is I want to load it first and load it first here as a string, and then use the system. So for example, what am I doing here? Okay, so I'm going to say using system.io. If I say file name is going to be p, what you're going to see is that what we get is the full-fledged file path, which is not what we want. So what we want is, so that we will want that for file path, for example. So for file path, we actually do want that p value, all right? But for file name, we're going to have to figure out how to retrieve just the name of the file from this whole thing. At that point, for that, we can probably also use the path object, the one that we have loaded with system.io. And I'm assuming there's gotta be something like get file name from a full path, right? So if I get file name from a full path, I'm assuming, yes, I'm going to be getting only the file name. And then for path, I can just use, as we have done before, get path, get directory name, and that's going to be P. If I do that, I can export here just the path of the current file that we are in. All right. Now, something that I would like to do though is that sometimes if we were to run this component, if we were to drop it in a file, in a Grasshopper file that has never been saved to the file, so you know how you open a new file and you still don't save it because you're just tinkering around with it. If you were to do that, then we would get some errors. So something that is quite useful to do is to first check if this grasshopper document dot is file path defined. So has this file been saved ever? And if that's the case, then we do all of this. We save this to the folder. So oh my god, it's kind of late already. I'm sorry, I'm a little messy. If that was true, then we generate all these outputs for the component. If it wasn't, then we just don't output anything. All right, more stuff. What about objects? I may want to output a count of how many objects are there in the document right now. So I can do that by saying this grasshopper document dot active objects, but you can see that this is a method, so I need to call it and I get a list of objects. So I get a list of objects that then I can just take the amount of objects from. I can use count to figure out how many there are. And it looks like my file has 281 active documents, active objects, which is kind of true because I'm working on this prototype for a Grasshopper plugin, etc., and it has a lot of components already. So you can see that I have 281. Is this true? Let me delete these two and recompute the solution. You see how the count went down by 2 units? And if I undo that and I recompute the solution, then this should go up by 2 units. Remember, I'm recomputing the solution because Grasshopper is designed to only recompute if a component changes inputs and outputs. If I delete a component, not the rest of the components don't get updated. Okay. And now the last thing is I can also get the thumbnail. So for example, if I do thumbnail, that's the output. What I can do is I can, from the Grasshopper document, I can retrieve the thumbnail as an object. And you can see that the thumbnail is an object that is not part of Grasshopper or Rhino. It's part of system drawing bitmap. What's interesting about that is that if I run this code, I get the system drawing bitmap, so which is an object that represents the thumbnail. But I can't really see the thumbnail, right? So what could I do to see the thumbnail here in Grasshopper? Well, I could write my own plugin or my own stuff that takes a bitmap and it turns into pixels and shows those pixels in the E.8 stuff. It's just that that's a little complicated. So for the sake of this exercise, I'm going to just rely on a library called Firefly from Andy Payne, who's also a good friend. And this library is really good for Arduino, utilities, networking, and computer vision. And in the computer vision part, there are some components that allow you to convert between system bitmap and Firefly images, which is the type that Firefly uses to render stuff. So I'm going to convert from system bitmap to a Firefly bitmap so that then I can use the bitmap painter to just view that thumbnail. And if I now save the file, and if I were to recompute, probably this thumbnail now changes to what I'm seeing right now. Can you see? And if I zoom in and I recompute, okay, I'm gonna recompute. And if I recompute, oh no, I have to save the file. Yeah, let me do something. I'm going to save the file and then I'm going to recompute because the thumbnail gets generated for files when they get saved. And also we got two more elements here. So I think that's kind of cool. It's quite meta, right? All right. Now, what is the next thing we're going to implement? Next thing we're going to try is we're going to use Grasshopper components to change the actual pre-visualization color of the geometry that Grasshopper renders on Rhino. Okay, that's going to be super easy and super cool. You know how the colors of the geometry that show in Rhino, the pre-visualization, is actually driven by this setting here. So you can see how the document preview settings for normal, I can make it blacker or more redder or whatever. And also for selected geometry, which is a different color, I can also click here and then just use a different color for selected geometry. So I'm going to do that programmatically. So I have dropped this random cube here that is currently being drawn with the default colors, which is red for all the geometry and green for the pre-selected one. What I would like to do is I would like to custom change that with some components, right? So how is that going to work? Well, first thing is I'm going to go into the component, and this is the one that is going to change the color of the normal pre-visualization. The way that works is that I can access the Grasshopper document, all right? And then here, what I can do is for the preview color, you can see that I have the two options, preview color and preview color selected. For the preview color, I can choose a color to set it to. But how do I define color? So let us take a look at this. So preview color, actually, I think it's written in the British way, preview color, exactly. The preview color property takes a color object, and color is actually not a type that lives in, it's not a type that lives in Grasshopper or in Rhino. It's actually a type that is from the C# core libraries, from system drawing in this case. So what I will need to do is I will need to make sure that I am first constructing an object with an object of a color object with the RGB values, and then using that object to change the preview. So how am I going to do that? It looks like I can create colors from names, but it also looks like I probably can create them from RGB colors. So for example, how do I do that? You can use the from RGB method to give it 4 integers or 3 integers and then create a color. So I'm going to do that. First of all, I'm going to load using system.drawing. And I know that because if I look at the color class, you can see that the namespace to which color belongs to is system drawing. So I need to have that available for me. Therefore, once I have that, I can create a variable of the type color and say this is going to be color from RGB. And then I can give it one RGB. Oops. I can give it one RGB, or the alpha. So I'm just going to use here RG and B. All right. And then I'm going to set this to be that variable that I just created. So I'm going to do that, and you can see that now the preview color all of a sudden just changed, and I can change it programmatically here, which is very cool. But it turns out that this is not great because the original one has a level of transparency, correct? So let me just add another input here, a integer, and I'm going to copy this. So this is going to be the level of alpha of that color, and I'm going to add this here. All right. So alpha right now is at 0, so it means fully transparent, and now it's a bit darker. How cool is this, huh? We're hacking Grasshopper from Grasshopper, okay? All right, and I wonder if I remove this, if the system color goes back to, no, it's already, whatever it is, it's already changed by this component. All right. Anyway, what about here? So we're going to add the same thing. I'm just going to add the alpha, and then the type here is going to be integer. I'm just going to copy the same slider here. And then here, we're going to do the exact same thing. We are going to say, I'm going to import the system. Oops, I'm going to import the system.drawing library namespace. Then I'm going to define a variable of the type color is going to be equal to a new object that I'm going to create from A, R, G, and B parameters. And then in this case, the Grasshopper document, I am going to change the preview color for selected, and I'm going to set it to this color here. If I do that, it looks like this has changed, but what I need to do is I need to select the object. And once it is selected, you can see that the color is changing. So now, for example, this is the color for selected, and this is the color for not. Not selected, selected, not selected, selected. And you can see how also the settings have also changed, which is kind of cool. So you can see that we can change programmatically from within Grasshopper the preview colors by just working with the properties of the Grasshopper document. Okay. Awesome. What else? What else? What are we doing now? I believe the last thing that I would like to do for this video is to do a small exercise on component manipulation. The idea is that we have seen examples of how to look at the Rhino document, how to look at the Grasshopper document, but within the Grasshopper document, there's all these components that all have their own properties, their own code, etc., etc. So something that I would like to do is to do a couple of examples of how can we look at other components from our code and how can we manipulate them in order to change their state or change certain things about the way they work and they show up inside of Grasshopper. Okay, so for example, I've made a really quick example here where I have a C# script component that I've called heavy calculation, which is basically a for loop that goes over, I don't know what it is, like 100 million times. And then it performs 100 million times, just adding one unit to this variable. This variable is of the type long because 100 million is more than the capacity of a regular integer. And then it's outputting that value here to the console. So if I do that, then you see that I get this number here. All right. And so what are we going to do now? So the idea is that I would like to write a component that takes, excuse me, I would like to take I would like to get a component, to write a component that, given a threshold, you can see that I have my profiler turned on, and my profiler is saying that this component took 260 milliseconds to execute. So what I would like to do is write a component, for example, that looks at the whole Grasshopper definition, finds out which components are the heaviest, which ones are taking the longest to execute. For example, all the components that take more than 100 milliseconds or less, or whatever I set the slider, and then to retrieve their names, how long it took them to execute, and their global unique identifier. And I will explain what that is and why that's important in a second. All right. So how are we going to do that? Well, it's actually not that difficult. It's just a little more lengthy than the other components. So I'm going to write the algorithm here, and then I will write the output somewhere. We've loosened like the good customs and writing clean code. So first of all, the first thing that I would like to do is I will need to retrieve an instance of all the objects that live in my Grasshopper document, so that then I can go each one over one by one, look at their execution time, and if it's over the threshold, then I cherry pick their names and their values. All right. So what is the first thing that I'm going to do? First of all, I'm going to I want to create empty lists for the names, the milliseconds, and the IDs that I'm going to be creating, that I'm going to be outputting for this component. So I'm going to create a list of names, and that's going to be a new list of string objects. All right, that's going to be a new list of string objects. And then I'm going to create another list of integer, which is going to be the millis or the computation time. And then last, I'm going to create a list of GUIDs, which is a specific class that represents basically a random string of letters and numbers that can be used for identification purposes. And again, I will talk about this later in a second. So I have my empty lists, okay? Then the next thing I'm going to do is I'm going to retrieve a copy of all the elements, of all the components that are active in my Grasshopper definition right now. So what I'm going to do is I'm going to say all the components, I'm going to take them by pinging the Grasshopper document and asking to get all the active documents. That is going to be returned as a list, all right? And if I were to actually, I would have to type this. So I could just use var and then get it over with. And this is probably going to work, although it's not working right now because names cannot be declared. Because I'm choosing the same names as this. Very smart for myself. So I'm going to call component names, component millis, and then component IDs. All right. So that was the problem, but this also works. However, I happen to like to type things so that I know exactly what I'm working with. And it turns out that the description of this, the autocomplete, was not giving me the full-fledged signature of the type of what I was being returned. So let's take a look then at the documentation. So active objects. So it looks like if the Grasshopper document has the active objects method, that's great. And the return type is a list of Grasshopper active objects. All right, so I'm going to copy that and I'm going to paste it here. And this is great because now I know that this list is not Grasshopper components or whatever, it's basically this data type. And what that means is that if I need to now figure out what can I read for component objects, I know that this is the type and therefore I can just go to IG active objects and see that components now have attributes, exposure, icons, whether if they're log, whether if they're obsolete, processor time. Oh, this sounds promising for what I want to do. Runtime message level, we've seen this before, is for giving them tiny messages on top. Add to document, add runtime message. We've also seen this clear data, expire solution. There's all the stuff that I can do on objects that live inside of the document. All right. So this is typically good practice, especially for tutorials. I like doing this so that we can all learn exactly what are we doing. All right. So now what I'm going to do is I'm going to go over each one of them and then try to figure out if these are the ones that if the component has, the processing time of that component is over my threshold, and then retrieve data for that. So for that, I'm going to use a for each component, and then I'm going to retrieve all these for each active object obj in components. Then, or maybe I'm going to do C in components. What I'm going to do is, first of all, I'm going to see if the component, if it's processor time, and the processor time is a complex object that has a lot of stuff. You can change things. You can get how many days it took, how many hours, etc. What I'm going to do is I'm going to read the property milliseconds of processor time. And if this is greater or equal than threshold, so that value that I set here, just for the time being to see if it works, I'm going to print here, found a heavy object. Just for testing, all right? I'm going to print to the console. I'm going to run this code. I'm going to plug a panel here. And you can see that I did find two heavy objects right now in my document. One of them is this one. The other one, I don't really know which one it is right now. I will need to look back. Okay, So that's working. So now what I want to do is from that object, I want to take its name, how many milliseconds it took, and its ID, and I want to store it in the list that is going to become the output. So what I want to do is I'm going to say to C names, I would like to add a property of this component. So C dot, and does it have a nickname? So the nickname is the one that you can override here. The name is the one, the original name that is immutable in Grasshopper. So I'm going to get the nickname, for example, and I'm going to add it to the list. So is this working? It is working. Oh, but I removed this and then I'm not outputting anything. So let me fix that. So names is going to be this list that I created called CNames. Millis, the output, is going to be this list that I created called CMillis. And then GUIDs is going to be this C IDs list that I created. And if I run this now, you can see that I have two components that are pretty heavy duty. One is the heavy calculation one, the one that I had here, and another one is mesh remesh. Can we go back to what we did previously? Can you see how mesh remesh is actually taking more than 100 milliseconds here, and the other ones are fine, are less than. So that's great. So this can be a really nice tool to give you a sense of some analysis of what's going on in your definition. All right, and maybe like track down where things are too heavy, etc., and maybe optimize. All right. How can we learn more? Well, let's take a look. So I did output the names. So to see millis, can I add C dot the processor time of that component in milliseconds? And if I run that, you can see that mesh remesh was 201 and heavy calculation is 260. All right, beautiful. And what about their IDs? So to see IDs, I'm going to add C dot what was it? Instance GUID. All right. This is not to be confused with ID. All right, component GUID, because all the C# script components, they all have the same component ID. All right. However, each one of them, each one that I drop on a component, they have a different instance GUID. This is because Grasshopper likes IDs for the component to be the same across the same component, so that the Grasshopper can say, oh, all of these are C# script components. However, I know that they're different because each one of them has a different instance ID. Okay, that is basically like your social security number is the same for all of us. It's different for all of us, but our DNA is almost identical. That's not a great example. Okay, but you know where I'm getting with this. So I'm going to use instance GUID, and I'm going to copy, and you can see that these are the IDs. Let me show you if I used component. If I used component ID, what I would get is the same ID for both, which is the ID for any C# script component. All right, so I'm going to use then instead instance GUID. All right, beautiful. So with this, I have been able to track down components that are expensive, that and I'm to try to figure out some information about these components. But now, say that I wanted to write something that changes those components and does something to those components. How can I do that? So the last thing we're going to do for this video, the last example, is going to be manipulation of existing components. The idea is that I may want to write a component that, given the IDs of a collection of components, what it does is it performs some kind of change in those components. There's many changes you can do, such as, for example, turning the pre-visualization on or off, locking the component or unlocking it, expiring the solution, etc. It just happens that expiring the solution is a little trickier because it also involves messing with the whole document itself. So I'm not going to do an example of that. But something that we can do is, for example, we can add a message. We can attach a message here to the bottom of the component in a very simple way. So what I'm going to do is I have this Grasshopper component, this C# script component that takes in an input here as a string. And that is also going to take the IDs of components. So for example, I'm going to plug this in here and I'm going to make sure that I right click and that the type hint in this case is going to be this particular one that may have gone unnoticed to you until today, which is GUID. So I'm going to force the input to be an ID for a component. And then what I'm going to do is I'm going to, in this component, I'm going to basically search any component that has this this global identifier, and then I'm going to make changes to that component. The first thing that I need to do then is I will need to find a component in my definition that has this GUID. Okay, so let's see what that looks like. So from my Grasshopper component, in my Grasshopper document, I can find, for example, I can find a component. And you can see that the options are the global ID or a system drawing point. I've actually never used this one, but I think you can find points, you can find components by location on the canvas, by nearby location. So I'm not even going to bother with that. So we're going to find the one that has this particular ID. All right. And as usual, I said this is going to be the result of that. I could just use, for example, the implicit type operator bar, but I don't like that. So I'm going to make sure that I know what type that is returning. I could do that by looking at the return type, and I can see that it's an IGH component type. So in this case, I don't really need to look at the documentation. I'm just going to say IGH dot component / component. And let's see if this is doing anything. So print dot nickname. Is that true? And you can see that I am getting two nicknames, so mesh and remesh and heavy calculation. So it means that this component is positively, it's working and it's finding those components by ID in the document. So what I would like to do now is just simply change something. So for example, C dot, I believe there's a message option, and that message, what I do is I override it with whatever is coming in from the component. Then you have heavy calculation here. So as I re-execute this, what you can see is that this message, heavy duty, was added to this component. And if I go to remeshing, probably, yes, we also have this message that got added here. I could, for example, do I have enough room here? I could just change this and say expensive calculation. And if I do that, that gets changed, or I could just simply delete it and remove all the messages. This is not great practice because if you're working with components that do their own message manipulation and they display information, etc., you're basically overriding that. So word of caution there. Perhaps a nicer trick would have been to just create a group around that component and then put a tag on that component. But I think at this point, I'm a little tired and I've been doing this all morning, so I'm going to leave that exercise to you, the viewer. If you can create a component that basically finds a component by ID, wraps it inside of a group, and then puts a tag on top of that group. That's actually quite nice to do. Why not? All right. If you actually do that, make sure to share that code with us here on the comments on the video or share it on Discord, and I will be more than happy to incorporate this code and give you credit in the sample files that we share with the rest of the community. Okay, beautiful. So that was the last example that I think I wanted to run with. We have seen how to read properties of the document, the Rhino document, the Grasshopper document. We have seen how to make changes on the properties of the Grasshopper document, for example, the color that we use for pre-visualization. And we have seen techniques, and these are very useful, to identify, search, and filter certain components on a Grasshopper definition, and also make changes to those components. And everything with code programmatically in a very meta way, if you will. Now, speaking of meta, what I would like to recommend to you as well is that everything that you have seen today is basically the building blocks of this amazing plugin that Andrew Human put together called Meta Hopper, which is all about finding things and modifying definitions and grouping things programmatically and creating components that allow you to search for things in your Grasshopper document and change those things in your Grasshopper document. It's super powerful, and you can see that document info also gives you the name of the document, the file path, components as a list. It gives you a lot of information. It's basically a much better version of what we just saw done today. But the code inside of the components is very similar to, it follows the same principles that we have seen here. All right. So if you want to learn more about that, go to Food for Rhino and search for Meta Hopper, and you will be able to download it and install and use another one, another amazing component, another amazing plugin by very prolific and very active in the open source and free community author Andrew Human. I'm a very big fan of his work. So that was it for today. Document components. I hope this was useful for you to understand the skeleton and how things work internally inside of Grasshopper, and to get a better, larger picture of how everything is interconnected. If this was helpful for you, as usual, maybe you want to consider liking this video, maybe you want to consider subscribing to the channel, saying a thank you word, or whatever sign of gratitude you are more inclined to. And in the meantime, thanks for being here, and I'll see you on the next videos in this series. Thanks a lot. Bye bye.